Hello, welcome to physics lesson electricity topic lesson 5. Okay, so this is the question. As we can see, it reads as follows: a television rated 110 volt, 550 watts. Calculate the cost of using such a television for 6 hours if the cost of electric energy is 80 kwacha per unit. Okay, so now in this case, let's calculate now the cost. Calculate the cost. Okay, so let's now calculate the cost. Number one, for us to calculate the cost, number one, we are going to calculate electrical energy. Number one, we are going to calculate electrical energy. Number two, that's when now we are going to calculate the electrical cost. Okay, these are the two steps that we are going to follow. Okay, so let's now follow number one, which is calculate the electrical energy. Okay, so in this case, electrical energy is equals to power times time. So electrical energy is equals to, what's the power in this question? The power is 550 watts. What I'm going to do now here, we're going to convert this 550 into kilowatts, because for us to calculate energy in this case under this topic, which is the cost of using electricity, under this lesson of cost of using electricity, under electricity topic, we probably use what? Kilowatts. So we're going to convert now. So we'll say this should be converted. We're going to convert this 550 watts. What I'm going to do, we'll say 1 kilowatt is equals to 1000 watts. Then now say here in this question we have been given 550 watts. So right now that one, which is 550 watts. 550 watts. So this is equals to x. Okay. So we'll say now 1000 times x. We're going to say 1000 times x is equals to then 550 times 1. Okay, so now here we say that 1000 times x, we are going to have 1000 x. This is equals to 550 times 1. This will be 550. And then at this point we are going to say over 1000. Over 1000. Here also over 1000. Okay, so 1000 to 1000, it's 1. 1 times x, x. Then 1000 into 550. Let's now calculate together. As you can see here, we are going to say 550, this one, divide by 1000. Divide by 1000. Okay, 550 divided by 1000. The answer is 0.55. So 0.55. So answer is 0.55 what? Kilowatt. So now we have calculated the electrical energy as 0.55 kilowatts. So we're going now to go back to the formula which we wrote. So we're going to substitute where we have electrical energy is equals to power times time. Where we have power, going to substitute with 0.55 kilowatt times, what's the time now in this question? The time is 6 hours. Okay, the television operated 6 hours. Okay, so now this is equals to, then we now multiply. Here we are going to say 0.55 times 6 times 6 times 6. 0.55 times 6. What's the answer? This is equal to 3.3. So the answer now here is 3.3 kilowatt hour, because this time is in hours. So 0.55 kilowatt hour times kilowatt times 6 hours. The answer is 3.3 kilowatt hour. Okay. Then at this point now we have calculated the electrical energy. Let's now go to the second one, which is second step. We are going to calculate the electrical cost. So to calculate the electrical cost now, let's now do it under this space. Okay. Just here. So here now we're going to say 1 kilowatt hour is equals to, so 1 kilowatt hour was costing what? 1 kilowatt hour was costing at 80 kwacha. 1 kilowatt was costing at 80 kwacha, because in the question it is saying that if the cost of electric energy is 80 kwacha per unit, so meaning that 1 kilowatt hour is equals to 80 kwacha, because 1 kilowatt hour is same as 1 unit. Are we together? 1 kilowatt hour is same as 1 unit. Okay, so now how many kilowatts was used? The power that was used was 3.3 kilowatt hour. So the power used was 3.3 kilowatt hour, which is equals to X. Okay, which is equals to X. Then we say, at this point we are going now to cross multiply. We do like this. Okay, we say 1 times X, this is the 1, is equals to 80 times 3.3. So we let down 80 times 3.3. 80 times 3.3. Okay. Then 1 times X, the answer is X is equals to 80 times 3.3. What's the answer? Let's use this device. Okay, so I'm going to say 80 times 3.3. Okay, so the answer here is 264. So now we write down now, this is equals to 264. So 264 what? Kwacha. 264 kwacha. So according to our question, the amount that was spent for 6 hours watching television, the amount was 264 kwacha. 264 kwacha. Then from there now, let's go to the second item. Question B reads as follows. What is the suitable fuse for this television? Okay. What's the suitable fuse? What's the suitable fuse? This one now. Okay. We know that the fuse is a device which prevents the electrical device from being damaged. So it's a sacrificial component of any electrical device, which is what it decomposes, or which is destroyed instead of destroying the device. Okay, so now at this point now, we was about to calculate the suitable fuse. Because the question says, what is the suitable fuse for this device? So now we are going to calculate the current which was flowing. After we calculate, that's when we are going to suggest the fuse which is suitable. So we are going to say power is equals to voltage times current. Okay, let's check now on top there. What's the power given? Power is 550. Let's write 550 is equals to 550 is equals to, what's our voltage? Our voltage is what? Let's check there. Our voltage is 110. So 110 times then current. Okay, so at this time now we have got this situation. So we'll say 550 is equals to 110 times I. The answer will be 110 I. Then at this point now, we are going to what? To make I a subject of the formula. So we'll say over 110, again here, over 110. Okay. So now, this into this will remain with I. This is equals to 110 into 50. Let's calculate. But even we can't even use the device. We just say 110 into 150. We just cancel 0, 0 and 0. We cancel them. 11 into 55. The answer is what? The answer is 5. Because 5 times 1 is 5. 5 times 1 is 5. So the answer here is 5 amps. So now let's go back to the question. Question is saying that what is the suitable fuse for this television? So if the current flowing in this television is 5 amps, this means that the fuse must be bigger than the current. Because if the current flowing and the fuse, they are the same, the fuse can be easily blown off. So here we are going to say the correct fuse should be 6.5. Okay, so we're going to say therefore the suitable fuse is therefore the suitable fuse is 6.5 amps. Why 6.5 amps? Because it is slightly bigger than 5 amps and it cannot be easily broken down. It can at least withstand some currents. Okay, so from there now, the lesson is that for you to know the fuse that must be used in a certain circuit, you must first know the amount of current. Then after you know the amount of current, then if it's 5, then the fuse should be at least 6.5 or 6. If it is it's 10, the fuse must at least be 11 or 11.5. Okay, we come now to the other question, which is saying that explain why a 5 amp fuse is not suitable for this television. The word not is underlined. So why is 5 not suitable? Okay, so the answer now will be, this is not suitable because it can easily blown off by electric current. That's how we are going to to say. So in this case, we are going to say explain why a 5 amp fuse is not suitable for this television. So we're going to say 5 amp fuse is not suitable. Is not suitable This is because it can be easily blown off. It can be easily blown off. It can be easily blown off since it is equal to the current flowing in the circuit. Since its value is equal to the current flowing in the circuit. Okay, let me read the answer once more. So 5 amp fuse is not suitable. This is because it can be easily blown off since its value is equal to the current flowing in the circuit. So this is the answer. Okay, so now in this case, this is now the end of this lesson. Please remember to subscribe and also to like this channel for more videos. Okay, thank you.